The Sleeping Beauty problem is a thought experiment that's had mathematicians and philosophers arguing amongst themselves for over 2 decades, and there's still no consensus. It creates a situation for them to argue about whether you should believe that there's a 1/2 or 1/3 chance that a fair coin landed on heads. So Sleeping Beauty was supposed to have lived happily ever after, but she's fallen on hard times since that prince guy kissed her awake. So she agrees to participate in a clinical trial for a sedation/amnesia drug. I don't know how it got past the ethics committee, but the researchers lay it all out for her before the experiment begins. They're gonna give her an injection and put her to sleep on Sunday. After she's out, they're gonna flip a fair coin, and that's gonna determine what happens next. If the coin comes up heads, they're gonna wake her up on Monday and ask her a question. Then they're gonna put her asleep again with some of that amnesia serum so she forgets that she's ever been woken up. Now if the coin comes up tails, they're gonna do the same thing on Monday. They wake her up, ask her the question, and give her the injection that makes her forget that she's ever been awoken. But in the tails scenario, they do the same thing on Tuesday. They wake her up again, ask her the question, and put her back to sleep with the sleep in and forgetting serum. So if the coin comes up heads, she'll only be awoken once by the time the experiment ends, and if the coin comes up tails, she'll be awoken twice before the experiment ends, but in either case, she won't remember nothing. So the question they ask her anytime they wake her up during the experiment is, what do you believe the probability is that the coin landed on heads? And this is where the arguments come in. The paper has been cited over 400 times on Google Scholar with over 100 pieces of literature on the subject, and there are 2 camps, halfers and thirders. Halfers argue that the coin is a fair coin, and Sleeping Beauty never learns any new information during the experiment. So the probability of a coin landing on heads is 1/2. Simple as that, and the rest is irrelevant. However, thirders argue that she should believe that there's only a 1 in 3 chance that the coin came up heads. See, there are 3 possible scenarios where she could be asked the question. The coin came up heads and she's asked on Monday. The coin came up tails and she's asked on Monday. Or the coin came up tails and she's asked on Tuesday. In the case of tails, she's woken up twice as many times. I flipped a coin 100 times and put down the results of the awakenings and the results of the flips in this chart here. Every time I flipped a heads, I logged it in the heads Monday pile, and every time I flipped a tails, I logged it in the tails Monday and Tuesday piles. That totaled out to 51 times a heads was flipped and 49 times a tails was flipped. Ugh, Jesus. But it totaled out to 51 awakenings that happened after a heads was flipped and 98 awakenings that happened after a tails was flipped. So a tails awakening occurred just under 2/3 of the time, and a heads awakening occurred just over 1/3 of the time. Halfers come in and point out that each time tails comes up, they come in sets of 2. You never actually change the dynamic of a coin. The results are always 50-50. I actually can't make up my mind on this. What do you think?